Assalamu alaikum. Hello everyone. This is a new video, my dear students. We are back. This exercise will deal with this set. Let A be equal to the set n minus 1 over n plus 1 cosine 2n pi over 3. N is a natural number from n. Find extremum, mean, and sup max if they exist. First of all, we can start slowly and with confidence. And we mean by n the numbers, the natural numbers, 1, 2. And we denote by an index 0. This means 0, 1, 2, and so on. Since here we have 3, it is more smart if we consider multiple of 3 to cancel divided by 3. What we can do? We can consider n equal 1 and 2 union 3k, k greater than or equal to 1. So we have here 1, 2, 3, 6, 9, and so on. Union 3k plus 1k greater than or equal. So here we have 4. We can do this. Union 3k plus 1 and 3k plus 2, k greater than or equal to 1. What we get? We get 1 and 2. For k equal 1, we have 3, 4, 5. For k equal 2, we have 6, 7, 8. For k equal 3, we have 9, 10, 11, and so on. So this is this for partition of n. With this very simple and basic decomposition, partition, we can write A as follows. So A is equal to, for n equal 1, we get 0. For n equal 2, we replace, we get 1 over 3. 1 over 3. Cosine 4p over 3. Union. For 3k, we get 3k minus 1 over 3k plus 1 cosine 2 times 3k pi over 3. For 3k plus 1, we get 3k plus 1 minus 1 over 3k plus 1 cosine 2 times 3k plus 1 pi over 3. And for the last, we get 3k plus 2 minus 1 over 3k plus 2 plus 1 cosine 2 times 3k plus 2 pi over 3. K greater than or equal what? Greater than or equal 1. We just replace. And the most important idea is in this partition. It's make it easy. And here we can simplify. We have 0 cosine 4 pi over 3 minus 1/2. So we have minus 1 over 6 from this one. For this one, we have union. For this one, we carry 3k minus 1. So 3k minus 1 over 3k plus 1. Cosine, so we simplify 3 with 3, and cosine 2k pi, 2k pi, k belongs to 1 plus infinity natural number, so this is 1. This is equal to 1. The second one, 3k plus 1 minus 1, so 3k over 3k plus 2. And here we have cosine, so we simplify 3 with 3 from this way, so we get cosine. Let me do it. Cosine 2k pi plus 2 pi over 3 for the second one. And this is exactly equal to cosine 2 pi over 3. This is a period which gives us times minus 1 over 2. And the last one, this one, 3k plus 2, so 3k plus 2 minus 1 plus 1 over what? 3k plus 3. 3k plus 3 times what? Times this one, so we get 3, which will be cancelled with 3, so we get 2k pi, the period, and cosine 2 4 over 3 pi. Cosine 2k pi plus 4 pi over 3. Here we have 2 pi over 3, yes, 4 pi over 3. This is the same as this one, which is equal to minus 1 over 2. This one times 2 sine minus, and here also minus 2 times this one, and here minus 2 times this one, k greater than or equal to 1. Final result is given by this set. All what we had to do is to make a subdivision, a partition of n smartly according to the number which is here, to get to avoid worst division. This is the basic and the elementary idea. Then we replace slowly and smartly. We get as a final result this one. what we can remark? We can remark that this sequence is increasing. It is an increasing sequence, and the limit is equal to 1. This is a decreasing sequence, and the limit is minus 1/2. And this is a decreasing sequence, and the limit is minus 1/2. But this one is less than this one, which means that the limit, the infimum of this set will be defined by the last one, this one, because this one is less than this one. As I told you in a previous video, we can use sometime the characterization, sequential characterization of infimum and supremum to decide about the limit, which is the infimum or the supremum. So this sequence gives us that the supremum, the sup of A is equal to 1, and both of these gives us that the infimum is minus 1/2, but we will use this one because it is less than this one, and the infimum of A is equal to 1/2. Let us prove by characterization, that the supremum is equal to 1. One has for any element x from A, x is less than or equal to 1. Any element. This is less than or equal to 1. This is less than or equal to 1. This is negative, so, and this is negative also. This is less than or equal to 1. We can just make the product, and we get 3k minus 1 less than 3k plus 1 minus 1 less than 1, so this is true. This is the first condition on the characterization. The second condition in the characterization, for any epsilon greater than 0, can we find an element x epsilon from A such that 1 minus epsilon less than x epsilon, which is less than or equal to 1. All the elements verify x is less than or equal to 1. Let us take this sequence, which is the greatest between all these for k large enough. X epsilon takes the form, 3k minus 1 over 3k plus 1. And why we choose just this one? Because it is the greatest, which goes to 1. This is greater than 1 minus epsilon. We search k0 such that we need k0, which verifies this formula. This is equivalent, and here we add plus 1 and we take off minus 1. We get 3k plus 1 minus 2 over 3k plus 1, equivalent to this formula. And from here, we divide 3k plus 1 with 3k plus 1, we get 1, and it remains minus 2 over 3k plus 1, which is equivalent to say that 1 minus 2 over 3k plus 1 plus 1 greater than 1 minus epsilon. We cancel, we simplify this 2, and we times by minus 1. This is equivalent to say 2 over 3k plus 1 less than epsilon, which is equivalent to say that 2 over epsilon less than 3k plus 1, and here we are near to finish. Why? Because this can be written as k greater than 2 over epsilon 1 over 3 minus 1, and we discuss if epsilon is greater large such that this is negative, any given natural number verifies this. If epsilon is short, this means that this is positive, and in this case we can take just the integer part of this value plus 1, which gives us the needed k. This finishes the characterization about the supremum. Does the maximum exist? No, we can never find a case such that this is equal to 1. In this case, we get a contradiction because we get minus 1 equal to 1. How about the infimum? We will deal with the same technique. I will just write it. For the infimum, we take this one and we verify that minus 1/2 is exactly the infimum using what? Using the characterization, property, characterization of the infimum. Using the characterization, this means that for all x in A, x is greater than or equal to minus 1/2, and the second condition for all epsilon greater than 0, there can we find an x epsilon from A such that what? Such that x epsilon is greater than or equal to minus 1 and strictly less than minus 1/2 plus epsilon. This is the formula. The form of x epsilon is of this form, and why of this form and not this form? Because this is less than this one. So the infimum will be given by this sequence, which is decreasing. And then we write minus 3k plus 1 over 2, 3k plus 3. We add 2 and we take off 2 to get minus 1. Minus 1/2 plus what we need, and we do exactly the same thing. We use the integer part, or we can use the fact that R is an Archimedean, the Archimedean axiom of R. By the way, Archimedean axiom can be as a consequence of completeness axiom, that this is a simple application, I mean proof. This is about this exercise. I hope that this video help you to more understand this topic. Thank you very much for watching. Hope see you next time in good health and good mood.